Good morning all. Today we are going to see about instruction execution and memory. The instruction execution in the sense the various registers are available in the microprocessor and microcontroller. So to execute that instruction there are some cycles are there. So those things only we are going to see today. So first before going to see about the instruction execution, let us see about what is computer registers. Registers are a type of computer memory used to quickly accept, store, and transfer data instructions that are being used immediately by the CPU. The registers used by the CPU are often termed as processor registers. A processor register may hold instruction, it can store addresses, or it can store any data which is after execution. The computer needs processor registers for manipulating data and a register for holding a memory address. The register holding the memory location is used to calculate the address of next instruction to be executed and the current instruction which is completed. So some of most commonly used registers are data registers. It is symbolized as DR. Number of bits used for data registers are 16 and it holds memory operand. The second type of registers are address register. The address register which holds address for the memory. The number of bits used for this address register is 12. And the most important register is accumulator because it is widely used for arithmetical and logical functions. So they are called as processor register and it is having 16 bits. And next type of instruction is instruction register. It holds the instruction code. Then program counter, that is PC, it holds the address of the instruction and it is very much useful for execution of your instruction. And temporary register, input register, output registers. So these are all some registers which is used for input and output operations. So next, while coming about this is the figure which shows the various instruction which is available on the basic computer. So input register, output register, temporary register. So with their bits, everything it is shown in this figure. So next, while we are coming about the memory unit has a capacity of 4096 words and each words contains 16 bits. The data register which contains 16 bit which hold operand read from the memory location. So memory location might be a main memory or it might be a prime or it might be a random access memory. The memory address register, which is widely used for program execution, it contains 12 bits which hold the address of the memory location. The next one, the program counter, it also contains 12 bits which holds the address of the next instruction to be read from the memory after the current instruction is executed. And next one is accumulator register. It is a general purpose register that already I said it is mainly used for arithmetical and logical operations. The instruction read from main memory is placed in the instruction register and temporary register, it is as the name suggests, it is used for holding temporary data during the processing. The input register which holds the input characters given by the user, either it can be through any kind of input devices, and the output register which holds the output after processing the input data. So next important part is about instruction execution cycle. So mostly in all computers there are two cycles which will be followed. One is fetch cycle and execution cycle. In recent processor and all, it is coming with 3-stage pipelining or 5-stage cycle or 7-stage instruction execution cycle was there. But these two are very common and it is necessary for executing your instruction. So there are additional components in computers such as I/O modules which can interact with the processor. In an improved instruction execution cycle, we can introduce 3 cycles which is known as interrupt cycle. So this is the figure to represent the instruction execution. So first it will be starting. Once the program got once the program want to run, first it will be fetching the instruction from the memory. Next it will be going for execution. So during execution, first it will be decoded. Once it is decoded, then it will be given to execution. So that is the second cycle. And third, during execution or during fetching, we need to check for interrupt. So if any interrupt occurs, automatically our processor goes to response the interrupt cycle. So once the execution got completed, either it may be go to halt, or it may be the program counter value may be increased and it will be going for fetching the next instruction. So this is the flow diagram of instruction execution. So what is fetch? So during fetch, what will happen? So fetch in the sense, some program, the program will be stored in the main memory. So we need to fetch the instruction from the main memory. So to start the fetch, first it will be started from the program counter, because the program counter already has the address of the next instruction. So first we will be fetching the address. It will be transferred to memory address register. So the memory address register, which will be used to collect the data. So and then it will be once the memory address register is connected with the memory, the data will be fetched from the main memory and it will be stored in the MBR. So the MBR is memory buffer register. So this will be happened through control unit. So this control unit is used to transfer the main memory to CPU for coordination purpose. To finish the cycle, the newly fetched instruction will be transferred to instruction register, and unless told otherwise, the CU increments the program counter to point the next address location in the memory. So this is the fetch and execution cycle. Once an instruction has been loaded into the instruction register and the control unit has examined and decoded the fetched instruction and determined the required course of action to take, the execution cycle can commence. Unlike the fetch cycle and interrupt cycle, both of which have a set of instruction sequence, the execute cycle can comprise some complex operations. So those operations can be categorized into the following four groups. One is CPU to memory, second one is CPU to IO, third one is data processing, and fourth one is control. So in CPU to memory, the data may be transferred from memory to the CPU or from the CPU to the memory. Similarly, CPU IO, the data may be transferred from an input-output device to the CPU or from CPU to IO module. And during data processing, the CPU may perform some arithmetic logical operations such as addition, subtraction, multiplication, and logical operations such as AND, OR, XOR, so those things. And the control unit that will be used to for an instruction may specify that sequence of operations may be altered. For example, the program counter may be updated with a new memory address to reflect that the next instruction fetch should be read from the new location. I have given one example, that is load accumulator to main memory. So here first the load operations can be first it will be transferred to memory address register. The memory address register will be interacting with the memory, and from the memory the instruction will be fetched, that will be stored in the memory buffer register. Then the memory buffer register will be transferred to accumulator. So this is how the whole cycle will be happened for load ACC, that is accumulator comma memory. Similarly, we can able to perform for add. So whatever the data which is available on the memory space, that one can be added with the accumulator. So next one, so this is the cycle. So CPU will be collected from the instruction register, and then MAR, then control unit, then MBR and accumulator. And this is for add ACC. The same kind of things will be happen for this also. And then the next, during interrupt, this is one of the important part. If any interrupt, so interrupt in the sense which is having highest priority among the other instruction. So once an interrupt occur, so it can be described by a mechanism in which an input output module that will break the normal sequence control of the CPU, and it will be given to the interrupter. The main advantage of using interrupt is the processor can be engaged in executing other instruction, while the IO modules connected to the computer are engaged in other operations. So these are all the some major interrupts. One is program interrupt, timer interrupt, input output interrupt, and hardware failure interrupt. So the program interrupt can be generated by some conditions that occurs as a result of an instruction execution, such as arithmetic overflow, division by zero, attempt to execute an illegal machine instruction, and reference outside a user's allowed memory space. The timer, which will be generated by a timer within the processor, this allows the operating system to perform certain function on a regular basis. Input output, which will be generated by an input output controller to signal normal completion of an operation, or to the signal a variety of errors conditions. The hardware failure generated by the failure such as power failure or memory priority. So this is the flow diagram. Once the interrupt occurs, what will happen? So first, the device controller or other system hardware issues an interrupt. The processor finishes the execution of current instruction. Then it will be giving acknowledgement to the interrupt signal. So then this is the most important part. Once the acknowledgement is given, the current program status will be stored into the PSW register, and program counter that will be stored into the stack. So once this process has done, the program counter value will be loaded with the interrupt value. So this is up to the part of hardware. Then the program counter will be loading with the new address, that is interrupt address. Then the interrupt process will be executed. So once the interrupt has done, then it will be restoring the information from the stack, and then the old PSW and PC value will be stored.